everybody, it's me Unhan and this is my sister Cute Cloud.
Hello. Hello. Bye. Bye.
Alright, and we're gonna be doing some trigonometric integrals. So let's do this. This is our first integral, the integral of cosine to the power of 3x dx. Okay, this is my new method, but I'm still gonna be using the old one for next time. Alright, so this one, how do we do this integral? To do this integral, let's try to use a Pythagorean identity. To be honest, I've done a lot of takes and this has been very annoying. Cosine square of x. Cosine of x. Using the Pythagorean identity, we can use 1 minus sine square of x. Cosine of x. Oh, don't forget the dx at the end. It must be with respect to x. So this is what we have so far. Now, to solve this simpler integral, simpler, not really simple, but it's a standard use substitution question. So I'm just gonna just u is equal to sine of x, then du is equal to cosine of x dx, then dx is equal to du over cosine of x. So this is what we have so far. Wait, I'm just gonna write this. Dx equals to du over the cosine of x. There. So this is what we have now. Now, all we have to do is use the substitution, and the cosines with this one will cancel out. So all we have to do now is just write the integral of 1 minus u squared with respect to u. Now this is simple, easy. Use the power rule. U minus 1 to 3 plus constant integration. And now all we have to do now is just replace it with replace it with a sine of x. Sine of x minus 1/3 of sine cubed of x plus c. And we are done. This is our first one. Now let's calculate a different integral. I'm gonna erase this first. Please comment down below about how this new method is. Well, actually I'm using following black pen red pen's method, but instead I'm using this whiteboard and a few other people's methods because other people has also used this one. In fact, I've seen a lot of people use this kind of methods. A lot. Alright. Evil marketing went to my nose. Yuck. Alright, anyway, now we're going to calculate the integral of cosine to the power of 5 of x dx. Notice that now, instead of a 3, the cosine, the power of cosine is now a 5. So now let's try to use the same method. This is equal to the integral of cosine square of x squared multiplied by cosine of x dx. And now with this information, all we have to do now is to use the Pythagorean identity again. The integral of 1 minus sine squared of x squared cosine of x dx. Phew, my hand hurts. Now again, this is a standard use substitution. So u is equal to sine of x du equals the cosine of x dx. And dx is equal to du over cosine of x. So now using this information, all we have to do now is just use the integral of 1 minus u squared du. Now that the cosine has cancelled out. Now, to calculate this integral, I'm just going to expand the integral first. The integral of 1 minus 2u squared plus u4 du. Now with this, all we have to do now is just calculate it using the reverse power rule. U minus, we use the power rule now. So now from here, we have to do u minus 2 u to the power of 3 over 3. Wait, I'm just going to do the 2/3 instead. U minus 2/3 u to the power of 3 plus 1/4 of u to the power of 1/5 u to the power of 5, like this. And now finally this is equal to, we just replace it, sine of x minus 2/3 of sine cube x plus 1/5 of sine to the power of 5 of x. This is our answer. Alright, now you got that, right? Alright, I'm just gonna erase it. Alright, so the two integrals we calculated in this video was the integral of cosine of x to the power of 3 dx, and the integral of the cosine to the power of 5 of x dx. Even though one of them is raised to the one of them is just a little higher, we can get a big difference. So we know the answers already, and this one, the answer to this one is sine of x minus 1/3 of sine cubed of x plus c. Here, like this, right? And now the answer to this one, remember, we got it. It's sine of x minus 2/3 of sine to the power of 3 x plus 1/5 of sine to the power of 5 of x plus c. And this is our answer. Alright, so these are the integrals we calculated for today. In fact, this is just part 1 of my actual vid of all of the integrals I'm gonna be here. And please subscribe to me and keep proud. Alright?
Yeah.
Please subscribe to her.
Yeah.
Alright. See you next time, everybody. Bye.